number 19.3 is a little bit confusing, like exactly what's happening here, so I think this is a good one to go over. So in 19.3 there's this ailment where people take their breath volume changes. They breathe every 5 seconds, start taking breath every 5 seconds, and their breaths start off small, and they take a big breath, and they take small breaths, take big breaths, take small breaths. And so we're supposed to model that with a sinusoidal function. So the first thing you always do is you draw a picture. And we try to draw it as accurate as possible. So here's our graph, and I really don't need to go negative like that because everything is going to be above the axis. Okay, they say first breath, smallest volume is 0.6, and this occurs for a breath that starts 5 seconds in the test. So let's put 5 here, and 0.6, and we'll just put it down low so we have room to go up. Doesn't matter if it's to scale with 0, because we know we're not going to go any lower than that. And then it gets to 1.8, 55 seconds in the test. that means that, way over here somewhere, so I'm going to try to be accurate here. This looks like 10, so this would be about 20, 30, 40, 50. I probably should have put my 5 a little closer, 60, so this would be 50, 60, so 55. It gets to 1.8, so let's put 1.8 way up here, 1.8, and at 55 it's 1.8. Okay, that's going to be a long sine curve, right? 5 seconds, it's right here, 0.6, 55 seconds, it's up here. Okay, so this is a low point, so it's halfway in between is where it crosses over. So see 5, 55, what's halfway in between 5 and 55? Add those together. So 5 plus 55 divided by 2, that would be 30 seconds. So 10, 20, 30, 40. So at 30 seconds it's halfway up, halfway in between the trough and the peak. So that would be at what's halfway in between 0.6 and 1.8. So 0.6 plus 1.8 divided by 2. That's not how you do it. Well, no, that works. So that would be what? Average of 0.6 to 1.8 is, that would be like 24 or 12. So 0.12. So 0.12 is halfway in the middle, which makes sense. 0.6 down, 0.6 up. So at 30 seconds, it's a 0.12, which is right there, halfway in between the bottom and the top. And then we want to draw a graph, and it's really tricky to draw sine waves this big. So it goes up, and then peaks, and then it starts coming down again. Okay, so this is from trough to peak. So that is 1/2 of the period, right? From peak to peak is a full period. So from trough to peak, that's 1/2 of the period of the wave. And that is 50 seconds. So that's 50 seconds. So the period, which we've been calling B then, would be 100 seconds, double that. Take the bottom to the top, and that means, or like bottom to bottom would be another 50 seconds, so 100 seconds. Okay, so we know right away our period's 50 seconds. And let's see, what else do we know? We want to model this as y is equal to a sine 2 pi over b times x, or t, it's nice to use t when we're dealing with time, t minus c plus d. Okay, d is the average, so d is going to be 0.12, right, the middle part, that's why we figured that out. D is 0.12. A is the amplitude, just from the average to the top or the average to the bottom, so it's 0.6. So A is 0.6. And then all we got to know is C. And one way to find C is you find a peak and subtract a quarter wavelength, 1/4 of the way, because it's always where it starts going up. Because remember, a regular sine wave looks like this, always starts at 0, and it's where in the middle where it starts going up, which is always a full wavelength is from here to here, a half wavelength is from here to here, and a fourth of a wavelength is from here to here. So if you know where a peak is, the point where it starts going up is always 1/4 of the length of the wave, or 1/4 of the period behind it. So we know that C then is the point of a peak, which is where here we know the peak is 55, minus 1/4 of the period, which the period here is 100. So 1/4 100 is 25. So 55 minus 25, 55 minus 25, which is equal to 30, which we knew that anyway because it's exactly halfway in between 5 and 55. But sometimes that's a tricky place to figure out. But you can always find C by taking a portion of a peak and subtracting 1/4 of the period. And there's multiple C's. C can be 30, and it can be 30 plus the period. So 30 plus 100, or 30 plus 2 periods, because it's where it starts over against any peak minus 1/4, and this peaks go on forever. So if C is the one thing you can have lots and lots of values for, it's usually best to take the smallest one. It's just nicer to have the smallest one, the one in the beginning, which is 30, right? Because the next one, it'd be 30 minus the period on this side, which would be 30 minus 100, which would be negative 70. So we don't want to go over there. So 30 is the best one to have. You can also find C by taking a trough and adding 1/4 of the period. So that would be, so C could also be 5 plus 1/4 of the period. So it's either peak minus 1/4 or a trough plus 1/4, which would be the same thing, right? Because that's 1/4 of 100, which would be 25, which would be 30. So those are different ways to figure out what C is, because that's usually the trickiest one. You want to find the point where in the middle between the peak and a trough. Okay, now we know what our function is. That's what A says. The breaths as a function of time is 0.6 times the sine of 2 pi over 100. Again, just leave it as 2 pi 1 over 100. Don't bother simplifying it. It's easier to read the period then. We know the period, oh, it's 100 right away. X minus 30 plus D, and D was 0.12. The average is 0.12. Okay, that's what A is. Now, for part B, they say if the patient begins the breath every 5 seconds, what are the breath volumes during the first minute of the test? Okay, so what they're saying is the breath volumes are going to be going up, right? Begins at, so every 5 seconds. So at 10 seconds, you know, how big is that point there? At 15 seconds, how big is that point there? At 20 seconds, how big is that point there? At 25 seconds, how big is it? And obviously it's going to go up. It's going to go from 0.6 all the way to 1.2 to 1.8, right at the very top. So for the first minute, we got to find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right, 12. Now we know what it is at 55 already, and we know what it is at 5. So we got to find 10 of those, which is kind of a hassle. Now actually we know what it is at 30 because it's 0.12. It's halfway in between. So okay, we know some of them, but we don't know what it is at 10. We know it's a little bigger than 0.6. Is it 0.7? Is it, you know? So what we got to do is use this equation. I am totally fine if you do it once or twice. You get the idea. This is a lot of calculator work, so this problem is really just making sure you can plug numbers into here. And why did I put an X there? It should be a T. I mean, X is okay, but when you're dealing with time, it's nice to put a T. So, okay, let's put in 1, and then again, the practice here is putting your calculator in radians. So let's say, what is the breath at 10 seconds? So at 10 seconds, you know, how big is this? It's going to be bigger than 0.6, should be like 0.65 or 0.7 or something, right? So we better get something like that. So it's 0.6 times the sine of 2 pi over 100 times, T is 10 here. So 10 minus 30 plus 1.2. Make sure your calculator's in radians. That's negative 20. That's important that it's negative. And then you plug all that stuff in, and it takes a while. So again, it's really good practice making sure you get an answer that makes sense. So let's see, that's negative 20 times 2 pi, so that's negative 40 times pi over 100, which is 40 over pi is 0.4, so that's sine of 0.4 times pi. Okay, I think I did that right. Negative. So 0.4 times pi. And I take the sine of that, make sure your calculator's in radians, times 0.6, and then add that to 1.2. And I get in my calculator that is keeping lots of decimal places, 629,366, then it's a 0, that's good enough. So make sure you can get that, plug it in yourself, make sure if you can get one of them again, that's fine. We don't need to do for 15 and 20 and 25. We know what it is for 30. Okay, but really it's important that you make sure you can get your calculator. And again, it makes sense, right? It's a little bit above 0.6, only 0.63, so it doesn't go up very fast, which in my very sketchy picture, yeah, mine looks like it goes down. But okay, so that's 19.3. Every problem, the trick is to figuring out the period, what's a full cycle. Again, if you know the trough and a peak, it's 2 times that. If you know the middle and where it starts, it's 4 times that. It's just really good to break up the wave into the parts, and then you can figure out C again. C is the X value. It's always where it starts. The wave starts 1/4 of the wave behind the peak, or 1/4 plus a trough. Lots of ways to think about it. It's just getting really comfortable dealing with sine waves and how these things work. Okay, thanks. Hope that helps. Bye.